Hello, my name is Kevin Clay, and I'm one of the Lean Six Sigma instructors here at Six Sigma Development Solutions Incorporated. Today, I'm going to give you a brief introduction to the one sample t-test using Minitab's version 20. First, let me introduce you to the statistical tool so that you understand kind of the background behind it, and then we'll move on. So the 1T test is a test which compares a hypothesized mean, actually it's a known standard or a set standard, to a distribution of data. That would be a number of data in a data set. All right, so it's basically comparing to see if the average of a data set is equal to this known or set standard. So this could be a set standard for the time to produce an order. All right, you have some kind of a internal company standard, and then we take data of the many times that these orders are created to see if we can meet that standard. Then the 1T test will compare the mean of that distribution of data to that set standard, and it will give you a difference between the two. And it will also give you the difference when it comes to that 95% confidence interval. So before we get into the tool, I'll give you a little background on the data you're looking at. The data you're looking at comes from a fictitious company called Peanut Butter and Jelly Inc. This company, this data, we use during our Lean Six Sigma Green Belt and Black Belt course. It follows a fictitious project. The Peanut Butter and Jelly Incorporated is seeing that their cost of producing a peanut butter and jelly sandwich is more than they thought it would be, more than they forecasted. So therefore, we are involved in a Greenbelt course in order to find out what the delta is. So this is part of a larger overall fictitious project that we give to our Greenbelt so that they have a benchmark to work from. Okay, so let's perform the analysis. The 1T test is found, actually it's found in a number of places in Minitab, but we are going to use the assistant because the assistant really does the heavy lifting for us. So we'll go into hypothesis test. You'll see here there's a dialog box. The assistant is a great tool because it helps you to understand where to go. Okay, so we are comparing one sample with a target. All right, we have a sample T. Basically, we're looking at the central tendency of the average in this case, comparing it to that standard. All right, I already have this filled in. Our data column, average PBJ, we are taking the average PBJ applied to a sandwich. And we have lots of data that show us the variation in that. Our target is 1.15. That's the amount of PBJ, excuse me, that should be added to the sandwich. Our alpha level is 0.05, which tells us we have a confidence interval of 95%. And then we have a difference of 0.05. I'm not going to talk about the difference here. If you have any questions about what this section means, go on to Minitab's website and search for the difference in a hypothesis test. All right, and you'll see a lot of great information there. So we've got our dialog box all filled in. Let's hit OK. All right, let's go all the way down to the bottom. The last graph, but we always do it first, or show it first. The last graph, really, it's not a graph, but last dialog box, I guess you would call it, is Minitab's report card. All right. So in the case of a 1T test, Minitab's report card is very informative. Actually tells us some things about our data, whether or not we can trust our data, or do we have the right amount of data, etc. So you'll see here that we've got two triangles with a exclamation mark in each one of them. All right, for normality and unusual data. Basically, what normality, what that is telling you is we may not have enough data to prove normality. Now, we might have a plot that fits a normal distribution, but this is saying that we might not have enough data to do that. Okay, now sample size. I'll go back up to unusual data in just a second. Sample size, it's saying that we have a good sample. And don't confuse that with normality. Sample size is just saying that we have enough data to sufficiently detect a difference between the standard hypothesized mean, or the standard, in this case 1.15, and the mean of the distribution. All right. But normality is telling us we may not have enough data to do that. Unusual data is, that's telling us that we might have some data that it's not really the normal. Okay, I wouldn't say normal, but it's outside of what we consider normal variation. Okay, so let's move up to the diagnostic report, right? Diagnostic report tells us that we do have some unusual data. All right, in this case, I and my team would stop, and we would say, what's causing that? Because that could be a signal, something that's actually happening within our process that could be the answer to our project potentially. We also see down here, it says, what is the chance of detecting a difference of 0.05? With our current our current sample of our population being 17, it's telling us that we have about almost the 57% chance of detecting a difference. Okay, that to me, that's not enough. So I would stop here again and say, okay, do we have the potential to take more data? All right, to understand where those points are that we can take data. Now, it might happen that we're stuck with this. We can't take more data. So we have to let our stakeholders know that we're doing an analysis, but again, this comes back and tells us that we have about a 60% chance of actually recognizing a difference. So there's some loss of confidence in that. Okay, last graph is the summary report. The summary report is just that. It's a summary of all the previous graphs, all right? And it gives you the answer in this case. Does the mean differ from 1.15? All right, with a p-value of 0.003 using the rules of hypothesis testing and the p-value, etc. We look at this, and with the confidence 95% confidence interval, we would say that yes, the mean differs from 1.105. All right, we have the mean here, which is 1.0725. That's the hypothesized mean. The mean can be anywhere between these two numbers. Again, earlier we saw that how are we able to, can we trust that number? I'm sorry, I was trying to think of the right word. Can we trust that number? Well, our earlier graph told us that, we can only see only have about a 60% chance of seeing the difference. So I don't know if you can really trust this number. And even with that, we still have a chance, again, to be wrong. We have comments. The comments are written in by Minitab. You can double click on this to edit the comments. All right, so you can put whatever the company nomenclature is in there, or you can just leave it like it is. Okay, so I hope that we are a little bit more educated on the 1T test. Again, my name is Kevin Clay, and I'm one of the Lean Six Sigma instructors here at Six Sigma Development Solutions Incorporated. If you have any questions, please don't hesitate to contact me. My email is kclay@sixsigmadsi.com. I will put that information down in the information below the YouTube video. And I hope that everybody has a wonderful day.